Okay, so now we're going to continue our discussion of the competitive equilibrium where only one period arrow securities are traded. And what we're going to focus on for a while is the role of debt limits. And a little background about competitive equilibria. I guess you'd call this philosophy or coffee time discussion. So think of the model with the general equilibrium model, with all trades being accomplished at time zero that we studied with Arrow de Breu. And the relationship between the planning problem and the competitive equilibrium. And we saw they had equivalent allocations. Kind of the notion. So you know, we did some formal arithmetic and math to describe the relationship between the two. But these models, as we mentioned, have great significance in terms of the theory of how to organize an economy, how to organize an allocation mechanism. And planning was the idea this was centralized. There was a benevolent planner with a Pareto criterion, Pareto weights that told people where to go. No prices. There were no prices. No prices. And competitive equilibrium, the spirit there was decentralized. That is, you know, we could use various words. Some of them are bluffs. They're descriptive, and if you push down and what do they mean, we could say invisible hand. I'll mention this in a minute. Invisible hand, that's Adam Smith's term. And decentralized, here there's prices. You know, for us, it was this, there were zillions of prices. You saw me get confused counting them, keeping track of them. There were lots of these prices. It was decentralized in the following sense. Well, here's the question. And this is, we're not going to talk much, we're not going to talk formally about this question. But some really smart guys like Samuelson, Arrow, and Hurwitz, they thought about it because earlier people like Edgeworth had thought about it. So the question is going to be, who sets prices? Who sets prices in this model? Who sets prices in the model? Or how are they set? The theory that we described is completely silent about that. It has no answer. These are prices that, if they were set in a certain way, and we described how they would be set, they solved all these equations, and you'll be solving some of these equations. If they were set in that way, then you don't need a planner. All you have to do is give every individual budget constraint and let them trade at those prices, and they will, person by person, they will choose the equilibrium allocation. But we don't have a theory about how these prices were set. Okay, so you know, various people, back to Valra, they thought about who might set prices. They talked about various kinds of mechanisms beyond the model. They amended the model to have these a theory of price adjustment. We're not going to talk about that theory. sort of applied workers, by and large, have kind of ignored that theory. I'm generalizing, and they've just gone with equilibrium prices. Okay, so the reason I'm mentioning this is once you start talking about, again, this is philosophy, who sets prices. It's kind of a insurrectionary it's a radical question. Once you start talking about that, you might start thinking about, well, actually, how decentralized is this? So people have had an auctioneer set prices. And what was the job of the auctioneer? Well, Ra talked about, well, the job, so if you read Ra, the auctioneer, well, he has to check budget constraints. For every person, he has to check this equation. That's all he has to check. CT minus YT. Just has to make sure that's true for every I, that nobody's spending more than they have. And there's, notice trade's not, there's just one budget constraint. Trade's not bilateral, it's completely multilateral. People are trading packages, huge packages. So if there were this, somebody's got to check that, but nobody inside the model is doing it. That's kind of this question. So, if there were this Walrasian auctioneer, you should ask Alberto Bassine about this, who's thought about this, knows more about this than lots of people, certainly me. What the auctioneer would be doing, the Walrasian auction, somehow he's setting these prices and he's checking this budget constraint. So why am I talking about this now? Well, when we talk about the model with Arrow Securities, which is a very popular model, we're going to see that we're going to kind of ask, how decentralized is it? And if there were this auctioneer, what would she be doing? What would the auctioneer have to be doing? Okay. These are a little bit vague questions. They've led to literatures. But you won't find this in the chapter, but it'll be kind of lurking on the edges. Okay, so now that's going to lead me to this topic of debt limits. Because when we do things with Arrow Securities, we're going to have to, there's going to be, unless we restrict people's ability to issue these securities, there's going to be a temptation to engage in Ponzi schemes all over the place. So debt limits are going to be very important. So what's going to, the equilibrium is going to involve equilibrium objects. We'll talk about this carefully. It's going to involve prices, a price system, and it's also going to involve debt limits, quantity limits. So these are quantities. So what's going to happen, and there's going to be lots of them, many. And to make this Arrow Securities model go, these debt limits are going to play an essential role. So if we thought of the auctioneer, if there was a counterpart of the auctioneer with Arrow Securities, that auctioneer is not just choosing prices to confront people with. He or she is choosing debt limits. Okay, so with that background, a little bit informal, more than a little bit, we're going to kind of proceed to the analysis. Okay, so and here's the way we're going to go. Remember, what we did a little bit earlier is we calculated this object, which was the tail wealth. In our Arrow-Debreu competitive equilibrium, time zero trading. That was the tail wealth. And every single individual had this sequence of stochastic process of tail wealths. And the competitive equilibrium determined this. This was a determined object. And we gave a formula for it. Okay. Okay, so what we're going to do, we're going to use the spirit. This has to be, unfortunately, we couldn't go and watch Arrow in the coffee shop when he's creating his paper, but as we said, I bet he's doing reverse engineering in the sense that he's starting with the Arrow-Debreu economy, and then he's from that, because he wants to create an economy with sequential trading that gives rise to the same equilibrium allocation. That's kind of the goal. He's going to start with Arrow-Debreu, and he's going to make some assumptions, and he's going to get Arrow. We already mentioned he's probably staring at this thing. He knows about that. So, and he knows about this, obviously. We're going to write this thing. This is going to be the thing that we computed. This is the Arrow-Debreu price system starting at tau, S tau for tau, for some tau greater than 0. For tau greater, it's for tau greater than or equal to t. So we're starting at t st, and we're pricing things for dates greater. So that's our continuation Arrow-Debreu price system. And there's a zillion of them, starting from every tau S tau pair in sight. Okay. So we're going to allow period to, I'm going to say borrow and land state contingent 1 period debt. State contingent 1 period debt. I'm being loose here, but you'll see why. At every node. And or they're gonna issue or buy 1 period claims, state contingent claims at fixed prices, prices that they're price takers. They take these prices as given. They're fixed to them. Okay, so I want you to think about you're a prospective lender in this economy, and someone comes and they want to borrow from you. I'm speaking loosely. So how much might you be willing to lend to them? So I'm gonna describe. I'm gonna name this object and try to sell this object to you as an intellectual construct. So here we go. We're going to go tau equals, this is going to be, what this is going to be, you're going to recognize it. We'll give it a name. I'll write it down first. S tau, starting from ST. We're at period T. I'm going to use this continuation pricing function that Arrow's got in his back pocket. Y tau I and S tau. I want you to, I want to think about constructing that. So suppose you're at date T at this, you compute this. So you look at this, say kind of what is it? Well, this is that's his endowment stream. That's the Arrow-Debreu continuation price for that endowment stream. And now I'm adding up all dates that happen at T and after, all dates at T and after for all histories that happen at T and after. I add those things up. So what this thing is it has a name. We'll give it a name. This is the present value at T of the agent I's endowment stream. And that's actually, so think about it, that's the present value. There's no consumption in there. So this is equal to, it's also equal to the maximum value this person, agent I, could ever repay, even if she sets CT, IST equal to 0 for all T greater than or equal to tau, for all S tau. Even if the person consumes 0 forever, they could never pay more than that. That's the present value of their endowment at which prices? We need prices to make this go. And that's why I say reverse engineering. These are, this is exogenous, but where did I get this from? Well, it's going to be taken from the Arrow-Debreu model. It's a continuation prices. Okay, so I'm going to construct that. And now I'm going to give it a name. And you'll find this name used all over macro and finance. Sometimes it's just thrown out. I'm going to call this, I'm going to call ATIST is, I'm going to leave space here. It's going to call it the debt limit at node T ST. And some people would call this, this has a name that goes, I think Rao Ayagari is the first one I heard this from. It's called the natural debt limit. Natural is a funny word. What it means, what he meant by that, it's the loosest possible. That's what he meant by the debt limit to make things work out. I think that's what he meant. So that's a debt limit, and we are going to impose that. We're going to impose that. So where do we get it from? We got it from this prior analysis that we just did. Okay. Okay, so with this said, I'm now going to, I'm going to give you a consumer's problem. in the competitive equilibrium economy with sequential trading. This is going to be sequential trading of one period arrow securities. Okay, so the first thing I'm going to have at each TST, okay, there's going to be, we're going to let Q sub T, put a twiddle on it for some reason, ST plus 1 given that history, that's equal to the price at TST now of 1 unit of the consumption good at time t plus 1 and state st plus 1. So that's the price of that's going to be the price that's faced for buying or selling a one period arrow security that pays off. It's going to pay off if next period state is equal to st plus 1. So if the state space is finite, that's going to be a vector. That's going to be a vector. And there's going to be one such vector for every history and every date. Okay. So there's going to be these prices. And the person's going to be a price taker. It's going to be a competitive equilibrium. And and what's the person going to buy or sell? So at each TST, let AT plus 1I, put a twiddle, of ST plus 1, given that you got to that history, be the number of units of time t plus 1 consumption at state st plus 1 purchased by person I. So that's what I bought. So now I can write down the budget constraint. I'm going to write down the budget constraint. So now I'm going to write down this person's budget constraint. Or now, how many budget constraints is this person going to have at TST? There's going to be one budget constraint at each possible trading point. So here it is. I know why I'm putting twiddles. I'm putting twiddles because this is going to be arrow securities. Okay, so that's my consumption today. And now I'm going to sum just over tomorrow's date. What am I going to buy? I'm going to buy these claims. I told you what I was going to buy. That's what I'm going to buy. That's my quantity. What do I have to pay for them? I got to pay QT ST plus 1 condition on ST. That history. It's a twiddle. That's what I buy. Now, what do I own? What I own is I own my endowment because I didn't sell it off now. I didn't sell it off beforehand. That's my endowment at this node. And what I did is I bought some claims earlier. So these are IOUs that come due. If the state is at that history, that's what this is. That's my endowment. So these are my resources today. These are today's resources. And what do? I divide them between, I consume some stuff, and then I buy or sell some claims on next period's consumption. So, tomorrow, this thing becomes this thing tomorrow. So that's one budget constraint. But that's not all. Because if that were all, stare at this. And now you could kind of see if you stare at this and say, what would you do? What would you do? Because I'm a price taker. So let's just stop here. Stop and stare. Okay. So you are a price taker. Okay, this stop and stare. Lots of people, they prove that was a great strategy for lots of people who became famous by writing important papers. They stopped at places like this and they stared at it. And then they asked themselves, well, suppose I was a trader, and I had a market participant, and I had the opportunity to trade at fixed prices. And I have in mind that Q, T, S, T plus 1, as they always were in the arrow. See, remember, we're starting this off for the arrow got these things from the arrow de Bruce prices, so they're always positive. They're non-negative. You could ask yourself why. You go back, look at our formulas for it. Okay, so I look at this and I'm a price taker. Means I can trade as much as I want. So let me tell you what I would do here. So here's what I do. I look at this and I say, okay, I come in and let's say today this is 1. And let's say I didn't buy anything yesterday. This is 0. So the right-hand side is 1 and 0. And I say the following. I'm a price taker. And I say, okay, I like to consume. I look at my utility function. I stare at this and I say, okay, let's set this to be a really huge number, 10 million. Well, if I make that 10 million, that's the only way I can do that is to make this this thing a really big number. I got to make this 10 million. I don't know what 10 million is. 10 to the 9th. I got to make this 10 to the 9th minus 1. No, I got to make it minus that. So what I'm going to do is I'm going to borrow. I face these given prices. I'm going to consume a lot today, and I'm going to issue claims on consumption tomorrow. I'm going to borrow. So so let's get the consequence of that. So I'm going to borrow in all states tomorrow. And then what's going to happen tomorrow, some state's going to be realized. I go to tomorrow, and now this thing's going to be a big negative number. But no problem. I'm just going to borrow more. I'm going to do this every period. And if this were my budget constraint, what I would do is I would make C arbitrarily big, and I would make the A's arbitrarily negative, and the budget constraint would always be satisfied, and I'd be really happy. So this budget constraint has to be, something has to be done to stop this. Okay, so what we have to do is, that's not the only constraint that the person faces. We're going to have to add another constraint. So here's the constraint I'm going to add. I'm going to say, whoops, you can't do that. I forgot to tell you, you have this constraint, minus at plus 1. So this is going to be a constraint at every t st. So you're going to face a whole bunch of these. These are going to be called debt limits. At plus 1 I, st plus 1. What's that? If I put a negative sign, that's your debt. That's your debt that you owe when you come into period, next period. That's your next period debt. I'm going to say that has to be less than the debt limit. And that debt limit was that's your debt limit. You cannot borrow more than your debt limit. And this is an important number. And how did we construct it? What is your debt limit? I already told you. Your debt limit is this thing. It's the natural debt limit, which we computed as, here we go. We computed as the present value of the tail of your endowment. And again, our logic was you could never pay back more than this. So what Arrow is going to do is what we're going to do following to make his construction go. We're going to have a budget constraint and a debt limit. And what the consumer is going to do is what the consumer wants to do is wants to maximize, well, we can do this. We can do this in several ways. We're going to think about the consumer realizes that this is the kind of economy he lives in. So our consumer has the same preferences as before. I'll write them down. At the beginning of time, the consumer realizes that this is what he or she wants to do. We write this down repeatedly. There's our communistic joint probability density at that date. Consumer wants to maximize, wants to choose what the consumer wants to do. It wants to maximize this with respect to what? A consumption plan. I'm being lazy about not putting twiddles on. I guess I should. And a portfolio plan. So it wants to choose a consumption and a portfolio plan every period to maximize this. That's the problem. Okay, so you're going to be better at solving this problem than I am. So here's how we're going to attack it. We're going to form a Lagrangian, and we're going to put sequences of Lagrange multipliers. We're going to put a multiplier eta t I of st. It's going to be a multiplier on every one of those constraints. And then we're going to put a multiplier, what are we going to call it? I don't know what my Greek letters are. I'm not literate enough in Greek letters. We're going to put a non-negative Lagrange multiplier on this. And then we're going to use the Lagrange multiplier theorem to get first order conditions. So that's what we're going to do next. And we're going to take, this is all with a given initial wealth. That's given in our problem. So think about how we're going to do that. So spend some time getting those first order conditions, and then we'll come back and we'll start talking about them.